Unit 4, Lesson 2. This lesson aligns with 3.6 in your textbooks. In this lesson, we're going to be dealing with the slopes of parallel and perpendicular lines, being able to use information to write equations in slope-intercept form for parallel and perpendicular lines. We're also going to find the distance between two parallel lines, and then at the end, we're going to go through a proof that shows why any two parallel lines are going to have the same slope. First example, use the information to write the equation of the line parallel to the given line and that goes through the given point. Okay, so our given line is y equals 4x minus 3, and we're going to through the point 5, 2. So the information we need, if this is going to be a parallel line, we know the slopes are going to be the same, and we have values for x and y. What we need to use is the point slope form for an equation. Y minus y1 is equal to m times the quantity x minus x1. We know our m, the slope, is 4 because they're parallel, they have to be the same. Our x value, or x sub 1, is 5, y sub 1 is 2. So plug those values in. We get y minus 2 equal to 4 times the quantity x minus 5. Now all we have to do is use some algebra, simplify, isolate y by itself. So we have y minus 2 equal to 4x minus 20. The last step, we would add 2 to both sides of the equation, leaving us with y equals 4x minus 18. So this is an equation that is parallel to the given equation and is going to go through the point, the ordered pair, 5, 2. Next example, very similar. The only difference is we're going to write the equation of a line perpendicular to the given line and goes through the given point. So we know the slope of our given line is 4. If we're looking for a perpendicular line, perpendicular lines have slopes that are opposite reciprocals. So the value of m in this case, the reciprocal would be 1/4, and the opposite, meaning it would be negative. Now we have the same setup as last time. We can use point slope form. Y minus 2 equal to negative 1/4 times the quantity x minus 5. Going through distributive property on the right, we get y minus 2 equal to negative 1/4 times x. Two negatives make a positive, so this would be plus 5/4. Last step, add 2 to the other side of the equation. That leaves us with y equals negative 1/4 x. Here we would have to get a common denominator. 2 is the same as 8 over 4. So 5/4 plus 8 over 4, this would be plus 13/4. So this is an equation of a line that is perpendicular to the given line and goes through the ordered pair 5, 2. In this next example, we want to find the distance between the two parallel lines. The first thing we have to do is find the slope of these parallel lines. So picking some points that are easy to work with, if I go up 1 over 2, that gets us a slope of 1/2. Now if we're finding the distance between these two parallel lines, that is going to be a perpendicular segment to both of these lines. Okay, so we know if that line is going to be, that segment is going to be perpendicular, then the slope is going to be the opposite reciprocal. So the slope of the line we need to create is going to be negative 2. So now I'm going to make a point on my first line using the slope we created. From this point, I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, gets me to a point on the other parallel line. Now if I connect these, we have a segment that represents the distance between these two parallel lines. Now we can identify both of these points. This would be 0, 1, 2, 3, 4, 5, 6. So that's the ordered pair 0, 6. And this is the ordered pair 3, 0. To find that distance, now we would use the distance formula and these 2 points to find what this distance is between these 2 parallel lines. So going through using the distance formula and simplifying, we get the distance to be equal to 3 times radical 5, which is going to be slightly larger than 6, might be close to 7. To end this lesson, we're going to go through a proof that shows why any 2 parallel lines are going to have the same slope. And this proof is going to be from a site called Khan Academy. I think it's going to be a lot easier for you to follow along with this proof.
What I want to do in this video is prove that parallel lines have the same slope. So let's draw some parallel lines here. So that's one line, and then let me draw another line that is parallel to that. I'm claiming that these are parallel lines. And now I'm going to draw some transversals here. So first let me draw a horizontal transversal. So just like that. And then let me do a vertical transversal. So just like that. And I'm assuming that the green one is horizontal and the blue one is vertical. So we assume that they are perpendicular to each other, that these intersect at right angles. And from this, I'm going to figure out, I'm going to use some parallel line angle properties to establish that this triangle and this triangle are similar, and then use that to establish that that both of these lines, both of these yellow lines, have the same slope. So actually, let me label some points here. So let's call that point A, point B, point C, point D, and point E. So let's see. First of all, we know that angle CED is going to be congruent to angle AEB because they're both right angles. So that's a right angle, and then that is a right angle right over there. We also know some things about corresponding angles for a transversal, where transversal intersects parallel lines. This angle corresponds to this angle if we look at the blue transversal as it intersects those 2 lines, and so they're going to have the same measure. They're going to be congruent. Now this angle on one side of this point B is going to also be congruent to that because they are vertical angles, and we've seen that multiple times before. And so we know that this angle, angle ABE, is congruent to angle ECD. Sometimes this is called alternate interior angles of a transversal and parallel lines. Well, if you look at triangle CED and triangle ABE, we see they already have 2 angles in common. So if they have 2 angles in common, well, their third angle has to be in common. So because this third angle is just going to be 180 minus these other 2, and so this third angle is just going to be 180 minus the other 2. And so just like that, we notice we have all 3 angles are the same in both of these triangles. Or they're not all the same, but all of the corresponding angles, I should say, are the same. This blue angle has the same measure as this blue angle. This magenta angle has the same measure as this magenta angle. And then the other angles are right angles. These are right triangles here. So we could say triangle AEB, is similar to triangle DEC, and we could say by angle. All the corresponding angles are congruent, so we are dealing with similar triangles. And so we know similar triangles, the ratio of corresponding sides are going to be the same. So we could say that the ratio of, let's say the ratio of BE, let me write this down. This is this side right over here. The ratio of BE to AE is going to be equal to, so that side over that side. Well, what is the corresponding side? The corresponding side to BE is side CE. So that's going to be the same as the ratio between CE and DE. And this just comes out of the similarity of the triangles, CE to DE. So once again, once we establish these triangles are similar, we can say the ratio of corresponding sides are going to be the same. Now, what is the ratio between BE and AE? The ratio between BE and AE. Well, that is the slope of this top line right over here. We could say that's the slope of line AB. Slope of line connecting A to B. Or actually, let me just use, I could write it like this. That is slope of line AB. Remember, slope is, when you're going from A to B, it's change in Y over change in X. So when you're going from A to B, your change in X is AE, and your change in Y is BE, or EB, however you want to refer to it. So this right over here is change in Y, and this over here is change in X. Well, now let's look at this second expression right over here, CE over DE. CE over DE. Well, now this is going to be change in Y over change in X between point C and D. So this right over here, this is the slope of line CD. And so just like that, by establishing similarity, we were able to see the ratio of corresponding sides are congruent, which shows us that the slopes of these two lines are going to be the same. And we are done.